Welcome to MOVI-C Cabinet and Decentralized VFDs 201. This is Session 5, What Goes On Inside the VFD. In this module, we're going to take a brief break from labs to talk about what goes on inside the VFD under the hood, as it were. It's important that you understand what's happening in the VFD because it's going to make the next few labs much more intelligible to you and overall explain the general mindset behind MOVI-C products. We're going to begin by talking about how the VFD performs motion. Now, I'm not referring here to what it's doing at the lowest level, generating the pulse width modulation that directly controls the motor. We're going to go up a level from there, and we're going to talk about what happens inside the VFD to do different kinds of motion. All MOVI-C VFDs contain basic motion control routines in their firmware called function control blocks, or FCBs. All the motion that a VFD produces, regardless of its origin, whether it comes as a command over a field bus from a PLC, or a switch, or a button on a keypad, all motion ultimately comes down to function control blocks. These are the things that produce various kinds of motion, and they are present in all the MOVI-C VFDs of all types. Everything under the big red umbrella contains these. These are the function control blocks. There are 18 of them, and as you can see, they do a variety of different types of motion. For example, FCB04 controls manual mode, FCB05 speed control, FCB09 position control. Each one of these produces a particular kind of motion, and some of them, as you can see, halt motion. For example, FCB14 produces an emergency stop. So there are many different kinds of motion, many different operations that the VFD will do. They're all produced by function control blocks, FCBs. A few facts about FCBs. Only one FCB can control the VFD at a time. That makes a lot of sense. You don't want one FCB telling the VFD to run and another telling it to stop, and the VFD gets confused and just picks one at random. You want a definite operation to occur. So the VFD is only going to listen to one at a time. But what happens if more than one tries to get control at once, which is entirely possible? Well, it's very simple. Function control blocks have a priority. The highest priority always wins. So if two FCBs are competing for control, the VFD looks at the priorities and picks the one with the higher one. Now, maybe you're thinking the priorities are numbered. Sorry, that would be too simple and logical. It's not the way it works. Here are the FCBs sorted by priority. Now, at least the highest priority FCB, output stage inhibit, actually is numbered 1, but the second highest priority is emergency stop, which is 14. I don't know why it's this way. It just is what it is. How do you know which FCB has control at a given moment? Well, that's very simple on a cabinet VFD. Just look at the display. The display tells you which FCB is in control. For example, if you see a 05 on the display, that means it's operating in speed control mode. Pretty simple. I'll mention here as an aside that the simpler VFDs like the MOVITrack Basic and Classic do not have 18 FCBs. They are simpler VFDs, therefore they can't do some of these operations. It would make no sense to include them. So they have a smaller number, but MOVIDrive Technology, MOVIDrive System, MOVIDrive Modular, they all have these 18 FCBs. The FCBs do the actual motion, but they need to get their information from somewhere telling them what to do, telling them, for example, how fast to run, how aggressively to accelerate or decelerate, things like that. Data sources, in other words. Well, it turns out the VFD has numerous data sources and control values that supply the FCBs with what they need to operate. These include things like set points, application limits, control words, process data words which come from outside from programmable logic controllers, and profile values. All these things feed the FCBs, and that is why I've used this particular picture here of an audio patch panel. In an audio patch panel, you plug cables between inputs and outputs that routes information to different systems. Well, within the VFD, there is kind of a virtual version of this. It's like virtual wiring. It links the data sources to the FCBs. Now, there are many, many different ways that you can connect things. You can establish these connections in multiple ways, and I'd like to take a look at that for a few minutes. Some FCBs are configured or controlled directly through MOVI-Suite. Now, when you're in MOVI-Suite, you go to the Functions menu, and then you find the Drive Functions menu and expand it. You will see all 18 FCBs there. And if you double-click on any one of those, you'll get its settings page, and in many cases, you'll be able to configure some of the data sources that feed the FCBs. I'm looking here at FCB 20, which controls jog mode. It has a lot of good examples of things you can set right through MOVI-Suite. For example, you can set the set points, which control the speed when you're jogging. You can just type those in as numbers. You can also set profiles, in this case how the VFD accelerates and decelerates when it's jogging. And there are also on-off switches which control which data source you want to look at. Each FCB is a little different though, so maybe take a quick browse through them just to see what you can do with them. Now we're leading up to our next lab. All the VFDs in the MOVI-C portfolio have digital inputs, and these digital inputs can activate and deactivate some FCBs, or they can modify their behavior. With the right combination of FCBs and digital signals, you can directly control the VFD. This is called terminal control. It's what we're going to be doing in our next lab. We're going to be using the switches connected up to the front panel of the VFD. We're going to use those to directly activate and deactivate FCBs and make the motor turn in various ways. All the MOVI-C VFDs can operate in terminal control mode. It's not very common to do that with the more sophisticated models, but it is possible. And in some cases, it's a very useful way to control a VFD. So we'll be doing that in our next lab, but I want to give you a peek at something else that's coming down the road. A much more powerful and easier solution to control the VFD is to use what's called a MOVIKIT. I've mentioned MOVIKITs a few times. We're going to talk about them in more detail right now. They are pre-written application programs that SEW Eurodrive has developed. They implement many kinds of motion. The idea here is that the MOVIKIT does a lot of the heavy lifting of motion control rather than you. You load a MOVIKIT, you configure it, and maybe it gets some commands from a PLC over a field bus, but the MOVIKIT does all the complicated work of producing the motion. Of course, it's doing that by accessing the different FCBs. Now, there are two different flavors of MOVIKITs. We'll talk about them both here. The first flavor is drive level. They run directly inside the VFD. You load them into the VFD, they run on its internal controller. There are 7 of these, and you can see them listed right here. The list is growing. SEW Eurodrive periodically introduces additional MOVIKITs. In most cases, the way these work is you load them into the VFD, and then you send them commands from a third-party PLC over the field bus, and they tell the MOVIKIT what to do. I'll mention as a quick aside, this is just a freebie here. SEW Eurodrive employees can develop custom drive-level MOVIKITs if you need one. We develop them in a language called DataFlex, which is an internal language. We use this to craft MOVIKITs. Now there's a second flavor. They are called controller-level MOVIKITs, and the name says it all. Controller-level MOVIKITs don't run inside the VFD. They run inside a MOVI-C controller that is connected to the VFD over our EtherCAT SBus Plus system bus. Now there are many different MOVIKITs available. Here's a small section of the total list. It's actually much bigger. SEW Eurodrive is constantly updating this list with new MOVIKITs, so there are many, many different ways to run your controller-based VFDs using this particular flavor. Again, in most cases, commands are sent from a third-party PLC to the controller over its field bus, and then the MOVIKIT running in the controller operates the VFD. In some cases, however, standalone programs running in the controller operate the MOVIKIT. So there are many possibilities here. Customers or SEW Eurodrive can develop custom programs that run in the controller using standard PLC programming languages. Important notes here. All the cabinet VFDs can run drive-level MOVIKITs, and any cabinet VFD equipped with EtherCAT S-Bus Plus can be connected to a MOVI-C controller running a controller-level MOVIKIT. There's a lot of flexibility available to you. I'll mention there are some gotchas. Certain VFD models have restrictions. They may not be able to run all drive-level MOVIKITs or all controller-level MOVIKITs. It depends on their capabilities. And that is the end of session 5. It was just a short little session to give you some useful information that should make the next session make a lot more sense. In the next session, we're going to explore terminal control with our VFDs. We're going to operate it by switches and a potentiometer. We'll see how that can be done. It's a quick and easy way to operate a VFD. That's our next session. See you then.